Okay, so we're gonna do homework one, problem one. So to calculate the E field at this point P, um, we're gonna use the same argument that this point right here, well, this unit area right here, so this small area with charge sigma is gonna cause the point P to repel that way, and then another piece right here is gonna cause the same that way, and it's the same for all points in this small um, uh, ring. So we know that the y components are gonna cancel. So here, here, they cancel. So the only contribution again is only on the x direction. So we only have ex. Now, the way we're gonna do this is that we know that dE is equal to k dq over r over the distance square, the just this distance here. We can find this distance because this is um, how much we increment in r. So this distance right here is gonna be little r, and then that just using Pythagorean terms, we know that x squared plus r squared equals to that side. And in this case, the variable that is changing is r, because as we increment, we're getting more and more circles. For example, if we increment to a place here, then the little r is gonna be all the way here, and so on. And now, um, we use this, and then we plug that in here. So that's k dq over x squared plus r squared, and then we know that this this contribution right here is from the cosine, so we just attach a cosine theta, and cosine theta is also equal to k q over x squared plus r squared times cosine theta is x, the adjacent over hypotenuse, so it's x over x squared plus r squared, x squared plus r squared 1/2 from here. Now, well, we almost have everything. So sorry, this is the q. So now we have k over dq x squared plus r squared 3/2, and all that is on the x direction. Now we want to integrate this because we know this is just the e. So we take the integral. Now, if we want to write dq in terms of something that we can actually integrate, we can take a look at here. So we know that dq is equal to sigma is equal to dq over dA. So we can multiply by dA both sides, so we get a. So we get a. We get sigma dA is equal to dq. And well, what is dA? dA, if we look at this ring right here, we know that this ring has some area. So this is dr. And if we extend this thing like this, so we cut it like this, and imagine just cut it, and then you're gonna have like something right here. So this side here is gonna be 2 pi r, and this side here is just dr. So the area of this thing, the dA is equal to 2 pi r dr. We plug that in here, so we get the integral. We get the integral of x k dq we plug that in here, 2 pi r dr all over x squared plus r squared 3/2. And then, well, from where to where we are integrating, well, we're going from 0 to r, because we want to get the whole radius. So we go from 0 to r, and z to to r. And now we can take out some of these things because they're constants. X is constant, k is constant, 2 pi is constant, and that's not constant. So we do x, k, 2 pi, and we only left with r dr over x squared plus r squared 3/2. And now we solve this by u substitution, so we'll let u equals x squared plus r squared, and then we know that du is equal to 2r equals to dr. And we substitute that in here, so we get x k 2 pi. We get r, which is just r, dr, which is du over 2r, and then this is u to the 3/2. This cancels, the 2 cancels with this one, and then we get x k pi, and then du. And for these ones, you can rewrite this as u to the negative 3/2. So you can integrate this. So you get du negative 3/2 du. Now, from here, well, we just take this and we can put it in here. So that's x k pi integral that thing. For these ones, the integral is just you do x n plus 1 over n plus 1. So the 1 here is just gonna be negative 2 times u to the negative 1/2. We evaluate, so we need to change to u, and we go x k pi negative 2, and then u is here. Okay, u is, and remember from here, u is x squared plus x squared plus r squared negative 1/2, and then we can integrate from 0 to r, and then we get an expression here. So to expand, so we get x k pi, and then we just plug in the numbers. So we get negative 2 times, and then we plug in the numbers here, so that's 1 over x squared plus r squared 1/2 minus 1 over 0. So this is, we plug in 0 in here, so that's just x squared to the 1/2. And we simplify that, so with the x k pi times negative 2 over, actually we can just pull that out. We get negative 2, and then we get this 1 over x squared plus r squared 1/2 minus 1 over x, and we're multiplying with distribute, so this is x k pi times negative negative, so that's 2. I'm gonna pull the k out, so I'm gonna rewrite k as the definition. So k is 1 over 4 pi epsilon 0, so we can write 1 over 4 pi epsilon 0, and we get x pi, and then we pull the 2 out, and then we get that, so we get 1 over x minus 1 over x squared plus r squared 1/2. So this is the so x q, that's good. And okay, here I forgot I to carry the lambda from here, so it's just I mean, just put the lambda here, so 2 lambda, and then that, sorry, the sigma, I define sigma, so sigma like that. We can cancel the pi's, we can cancel the 2 and the 4, so you get sigma x over 2 epsilon 0, and then 1 over x minus 1 over x squared plus r squared 1/2. And this is your E field at point P.